my name is Sharon Gardner, and this is my final presentation for data interoperability. The data set I chose to analyze is the dataanime.csv as seen here in the Excel file. As you can see at the top with the columns, it's pretty standard. It would be similar to what you would find in most library databases. One or two things of note are the fact that several of the columns, such as genres, have comma separated values within that element, and that you will notice that there's actually quite a few null values. Those have been filled in as dashes, so those also had to be taken into account. Now, with the first file I did, it was converting. Well, the very first thing I did was analyzing the size, shape, and frame of the database, because that's not always something that you're going to know if you just get sent a file. So with this, it calculates the size, which is the total number of elements or cells, shape, which counts the number of rows and columns in the data frame, and then does a quick calculation to just verify that all the information matches. The items that are commented out in here are for those that are working with data sets that would be in engineering or in something like 3D. So once you run it, in this case, it tells me that I have 31,260 cells to work with, 1,563 rows, and 20 columns. From there, I went on to do conversions, and with that, I did several rounds of conversions, and you can kind of see on the screen here, I've done convert to HTML, two versions of it. I can either do a straight CSV to HTML conversion or a split. I'm choosing to focus on the split because the split is actually where you're going to create something like an anime quick guide that can be attached to a library web page. With this, we're looking at columns, picking out the columns that we want to add to the HTML page. You'll see up here at the top it talks about web browser. Web browser is an automatic Python library. It's already built in, and when you use web browser, open new tab, it will automatically open the newly created file in your default web browser. And in this case, I chose title, studios, rating, and description. So as you can see here, it's a fairly quick way to build a guide or a supplement to a library web page. From there, I chose to go ahead and convert to JSON. I have three different methods of converting to JSON, but the one that's going to do us the most good going forward is the convert 3 to JSON. As you can see, it builds in a full array with the squared out brackets, appends the rows, reads it in, converts it, and from there we end up with the results we see here, which are much prettier. So it's more like a pretty print with the squared brackets containing the entire array. From the JSON, so we've moved from CSV to HTML, then CSV to JSON. JSON is going to go to XML. XML, the JSON to XML here, we're building the overall element, the container element, works XML, the internal element for each of the sub elements, the individual records, sets of records, which is work. It will automatically figure out what each sub-element is, use those names, and create the XML file while creating a declaration that's true. And with that, what we see is, if I can get my computer to work, so the XML file, and I'm just going to open this with internet Explorer. And as you can see, it's structured very much like you would find on a XML web document. Now, from the JSON, I also did a conversion from CSV to XML, which is something that we did in a lab prior in a previous project. But I also did XML to CSV. With this, it was a little bit more structured because I had to actually iterate over each element in the root to find it. The get attribute that you notice on here, these slightly different strings, are the get attribute was to take care of any special characters or unusual spacing, anything that could have affected pulling that data, because element find just defaults. It will create it will read it and go, okay, this is a string, or okay, this is integers. So with all of this, the get attribute kind of fixes that problem without having to do a lot of extra coding. And then once the final CSV data and structure is done, you can see I've gone back to listing all the column headers, setting it up as a data frame, writing the data frame to CSV. And what ends up happening is that when you look, you will see that CSV file. Open with Excel. And we're pretty much right back to where we started, except that you will notice that on the headers, instead of start space airing, it's start dash airing. Things like that. There is two other types of conversions that I wanted to discuss. One is converting to text, the results to text, and then converting the text to PDF. So I think everybody knows how to convert their results to text, their outputs to text, so I'm not going to worry about that. But text to PDF is different. What this does is it takes your PDF, your text rather, and converts it to PDF using FPDF. And with this, it works a lot like a stripped down Google Docs. You have your format, orientation, font size. In this case, you must add page, PDF add page. If you do not have that, the file will not run because it has nowhere to write to. Because I wanted to make sure that the file would write correctly without cutting it off any of the wording, I figured out how to do effective page width, which automatically calculates the page width based on the format, which is a letter, which is standard. You also see down here that it talks about multi-cell. This allows for natural breaks in the text and looks a lot more natural when you're looking at it. And the results of that you can see here in README 2. This is a text file, my README text that I converted to a full PDF. After all of these, what I did was I went into my files and created plots. So first, I did splits for the plots, as you can see here in my listings for my files, but the important thing was the outputs. So for example, the first plot figure I did was a donut style plot, and this covered the number of times a rating was found in the main CSV file. Anytime you work with a donut or round style plot, you can actually explode a portion of it or cause it to bump out slightly to give it some extra attention. And you can, even though normally your legend is defaulted to the best possible location, you can actually change its location by using lock equals and then just adding in coordinates. So, for example, this is my ratings by series count and percentage. And as you can see, it gives me the rating, the total percentage of the count, and how many. So 1040 series were rated PG-13. For the next one, it was, yes, I want to kill it. The next one that I was doing was, my second plot is a pie plot. And with that, you will see that it's how often the type was listed in the main CSV file. So movie, music, ONA, OVA, special, and TV. Again, we have our plot, we have our floated legend. So 52%, a little over 52.5%, were actually based on TV's series, and it was 821 series altogether. Now, from there, I went on and did additional analyses that were separate, and what I did was I did several analyses. What it was this one is basic statistics based on the CSV. So your mean, median, sum, max, min, standard variations, deviations, episode values. And what I did was I wrote it into the text file. So this gives me all of this information, which I remember to move mine. Okay. Analysis. CSV. So the text output, which I keep clicking on the wrong one, is here, and as you can see, it gives me the mean, sum, max, min, count of shows, median of episodes, all that good stuff. And it shows some of the episodes grouped by their specific genres. And each one of these is a separate genre, believe it or not. There's 1,003. And I'll show you how I know that in a minute. But towards the bottom, you'll notice that it starts getting into, because I went too far, the count of occurrences grouped by genre. So this is the number of times this was episodes. This is the actual count of the shows. So with the count of the shows, a second analysis I did was a genre analysis, and with this, it showed the genre and the sum for each genre. So again, we're looking at 1,000, and it's a lot, 1,003. And then the genre combination with the most series associated with it is slice of life comedy at 16, which is right here. So I did my CSV analysis. I also did a JSON analysis. The JSON analysis works a little bit different. What it does is, with the JSON analysis, what I'm doing is I am iterating through the entire file within the starting season column or element, and I'm looking for anything that's marked fall. It's going to list whether or not it's found at that record location, and then it's going to count it up at the end. Now, if you know for a fact which location your data is set in, like if you know, for example, in a comma separated string that aniplex, that happens to be your search key, is always in position 0, you can just go ahead and use the code that's commented out here, because you can narrow it down to the split, producers, and then you can pull anything that's aniplex in position 0. Same thing with genre, but with this you're going to see slightly different results. And okay, so fall not found. Fall found at index 0. I popped this out as a list item so that way it would be a little bit more distinctive in this file. And towards the end, what it does is it counts up the number of occurrences for the search key. So fall showed up 275 times. That's a lot. Generally, series come out spring or fall. There's not as much summer in Japan in terms of releases. So the last round of analyses I did was in the XML file, which, if I can find it, XML text, XML stats analysis. Okay, so this searches specific values, then counts them. This works a little bit different. So my block, I started out with a count. I started out with a 0 count. I split the producers. I looked for the producers in XML. I split the comma separated string. I went to find the specific item, Nitro Plus, used the counter here, and then wrote it out as a list. Same thing with genres, except that I'm using magic. It's going to add it up at the end, but you're going to see that the results end up being visually very different. There's going to be two sets of results. In the shell, what you're seeing coming out is the comma separated strings broken out, and with that you'll see that it's just showing the actual values instead of going found not found. So at the bottom it shows you your value counts, and now with that, let's see. All of my code is going to be available with this presentation. So if anyone has any questions, please, I do recommend you follow the README, but if you still don't know, please, please, please always feel free to reach out. Thank you very much for watching my presentation.